Hey friends, welcome back, and today I've got another astronomy video for you. So after the last video where I took you on a bicycle ride across the path of the planets, the Planetenweg, which is a very awesome model of our own solar system. It's close to my place. It's 1 to 1 billionth, so 1 millimeter in this model equals 1000 kilometers. Well, after that video I thought to myself, why not build a model in the same scale but of another solar system, just to see the differences there. Like, it's amazing how different solar systems can be. This model back here, I have it ready already, is of the Trappist-1 solar system. Some of you astronomy nerds might have heard of that. It's a system that's around a red dwarf star, quite a small one. It contains 7 rocky planets. They're all more or less the size of the Earth, but like the orbits, how far away these planets span, like the furthest one, it is not even as far as Mercury is from our Sun. It's actually more comparable to the Jupiter system with its 4 big moons, like from the distances. So it's tiny. But nevertheless, I'll show you the model quickly and then we'll go set it up besides the proper model of our solar system. Here we go. So just before we get to the river to set it up, quick look at the model. So this would be the main gravity well, the red dwarf star. I made like some little tags with some information. It's all in German though, just that the locals can understand it. Yeah, these are like the planets, Trappist-1b, 1c. It goes over to D, E, F, G, and H is the outermost planet. These here are all more or less to scale. I tried to paint them a little bit according to how they maybe look. Of course, we don't really know that in detail, but that's for future telescopes to find out. Well, I would say let's get this stuff packed up, get to the river, and set the model up. So here we are. I just set up the model of the Trappist-1 system beside the model of our own solar system. Let's take a quick look. Let's make a quick walkthrough. So this is our tiny red dwarf star, the gravity well of the Trappist-1 system. Compared to the massive sun up there, that represents our own sun, which is, I think, 12 times bigger than the central star of the Trappist-1 system. I also put some notes here just for the locals that they know what it's about. It's all in German, so it won't help you guys so much probably. But let's go to the first planet here. This is all in the same scale like the big sun from our own solar system, so this should be actually, correct to scale. First planet we have is Trappist-1b. Trappist-1a will refer to the star, just that you know. Earth-sized planet, it's very close in. It has like the 1 year on Trappist-1b is only like 1.5 days. It circles its own star in 1.5 days, so it's really close in. Also, I think we have confirmed atmospheres on, I think, more than half of the planets actually. The inner ones, they kind of confirmed that they have atmospheres. So it's a bit difficult to say the surface temperature with an atmosphere. I wrote down the surface temperatures here. This is Trappist-1c, the the second most inner planet. But the surface temperatures, they're really relative. They can't really prove them. It's only a calculation. Like if there's an atmosphere, that would influence the surface temperature quite a lot. So back here, this is only like 2 or 3 meters away from the host star is Trappist-1D. And here we're entering the habitable zone. So this planet, maybe even the one before, has quite good chances of like nice conditions. I won't say like there's life there, but it's a maybe life. It has good chances. We don't know that so exactly yet. We'll have to wait for much better telescopes to come online to really get like any details from the planets. It's difficult to say more than if it has an atmosphere and, you know, orbit time, stuff like that. That's what they can do now, but details are very difficult. I think Trappist-1E also has good chances for like liquid water and maybe even a biosphere, who knows. Then we're getting a bit more out. Here it'll get colder, so maybe we could have a similar situation to the ice moons of Jupiter and Saturn. This could be something similar to Europa or to Enceladus, where you have an icy crust, but there's maybe still a warm core and an ocean in between. Also, we don't know that, but I like to imagine it could be that way. Further out, now distances are also increasing a bit. You kind of see how gravity works. It's kind of interesting. We have 1G here, which is the second outermost planet. It orbits in like 12.3 days around its star. It's still quite a fast year, I think, like compared to our planets of our solar system that we know. And out here we have the smallest one, actually. It's funny, well, if you compare it to our solar system, it reminds me of Pluto a little bit, even though I know Pluto doesn't count anymore, but I'm a Pluto fan, so I still count it. So after we took a look at the Trappist-1 system, just to remind you, this is all the same scale like our solar system. In this model it's 1 to 1 billion, so 1 millimeter is 1,000 kilometers. After we looked at this system, let's take a walk to Mercury. Mercury is up there, it's, I'd say like 70 meters away, like just come along. And I think this is really fascinating to see the distances, like our innermost planet, which is Mercury, which also orbits rather fast, is still this much further away from our sun than like the outermost planet of the Trappist-1 system. It's really an extreme difference in sizes, if you imagine. So, almost here. You must faster than us. You like Mercury? So this here is planet Mercury. Also the size should be more or less comparable to our model. It's not perfect, but I try to stay about 10% error margin for my scaling, but I think it's quite okay. And maybe we can look back and try to see our model. I'm not sure if you can see it on the camera. Also, there's a pedestrian in the way right now, but we're really far away. That's what I mean, that's what I wanted to show. So we walked back from Mercury to the Trappist-1 model. Just was some small idea that I had. I think it's neat to see the size differences. I mean, there's also much bigger stars than our sun. There's like, you get a whole catalog of sizes, and I'd like to imagine how a solar system around one of those really big stars look like, but then just to remind you, in this model, Pluto is 6 kilometers down here. So yeah, solar systems come in all kinds of sizes and forms. That's what I wanted to show you. I think I'll end the video here. Thanks for watching. Thank you to Jaqueline and to Yuma for helping filming this, and see you soon for our next video. Bye!